All right, if you're watching this video, you're here to hear about Capella Columnar, which is a new database as a service offering from Couchbase in the cloud. Somebody somewhere told you that there's this great new thing you should hear about. And so my job today is to tell you what that thing is. And so you're looking at the name Capella Columnar, and you might form some opinions about what that might be. And I'm here to sort of tell you how much technology we have under the hood, and also what kind of functionality we offer over the hood, all part of this new thing called Capella Columnar. I'm Mike Carey. I'm a consulting architect for Couchbase. All right, so what am I going to do? I'm going to take you through sort of 4 pieces of this talk. The largest piece will be the third part. But first of all, I'm just going to explain to you why you might want what we call JSON analytics. Why is it based on JSON? Like, why is JSON a big deal? What is Capella Columnar? Sort of overall, what does it provide, and roughly what does it look like? And then what I really want to do is spend a little time on each of the technologies, the cool things that are under the hood of Capella Columnar, to give you an appreciation for sort of what's in the box in the cloud. And then I'll wrap up and talk to you about what's coming. So we're going to go through that, and let's get started. All right, so first of all, most of you probably are very familiar with the notion of JSON and what it is, but I want to make sure we're all on the same page to start. So why is JSON important, and even what is JSON? So JSON is short for JavaScript Object Notation. In a nutshell, it's a lightweight format, a text format, with a very simple spec compared to sort of previous standards. It's readable and writable. So JSON data is not too hard for humans to read and write, and also very easy for machines to read and write. So it's a nice format for meeting the needs of both people and processing engines. Objects in JSON are built up of primitive types and flexible records that can have variable numbers of fields and things, and also arrays. And these can be combined, as we'll see in examples that we'll be covering. It's widely used in the world today for exchanging data and for building web applications. And it's also very common underneath sort of applications that have bits and pieces of AI in them. So it's a format of choice for those kinds of applications. And the cool thing about JSON is that it's kind of a general data model. You can sort of think of it as a universal way to look at data. If you put on JSON glasses, you can, and you sort of squint, you can see relational tables as collections of JSON objects. You can see sort of document collections and document databases like Couchbase or MongoDB or others as collections of JSON objects. You can see data that's in files, comma-separated, tab-separated files, parquet files can be seen as sort of virtually as JSON objects, and even application data. Things like a shopping cart can be nicely modeled with JSON. So it's a very nice model for kind of looking at more general, more flexible kind of data. Capella Columnar brings sort of data analysis to JSON data. So what is Capella Columnar? And first, why do we have this thing called Capella Columnar? What were we thinking when we built this? Like, we already have relational data warehouses. We've had them for decades. Data lakes, last 10, 15 years have become very popular. Why is that not enough? Well, first of all, I want to acknowledge that the relational model has been wonderful, right? It's served us well for literally for 5 decades. We have the SQL language, structured query language, which makes for simple querying that you can use to basically manage and query your data. We have this notion of data independence from the relational model. So you see your data as these tables, and you can query them using SQL, and under the hood, the file structures can be complicated. You can have indexes and things, and they're not visible to you if you're using the system from the outside. So that's called data independence, and is a very important piece of why relational is successful and why SQL is important. There have been decades, literally decades, of research on SQL query processing and how to do parallel execution of SQL queries. And so all those things are great from relational data warehouses. But sort of the limitations that are really hitting us are that relational databases want to see your data as flat tables. They want to know, like, what are the columns and rows of your tables? What data types are they? Tell me that up front before I'll work with your data. And if you want to make changes, that can be challenging, right? So if you have an application and you've got some new info that you want to record in that application, you have to go and sort of change the structure of your tables. So they're very rigid. And JSON is important. And so what do we do with JSON and relational data warehouses or data lakes? The typical answer is, well, we'll give you one more column type called JSON, and you can stick your JSON data there. And so it's sort of like a bolt-on or a glue-on, an afterthought, typically in things like relational data warehouses, right? So sort of here we sort of pictured sort of the world. Here's a data lake, here's a data warehouse, and these, sort of the observers of the data lake are thinking rigid, because you have to have this schema. Everything has to be uniform. So what Capella Columnar does is brings the decades of research and knowledge and the declarative querying and the data independence from the world of relational to bear on flexible JSON data. And so the result is that Capella Columnar offers a really good platform for doing JSON analytics. The language for interacting with your data is very familiar to those who are familiar with SQL. It's an extension of SQL for JSON. So basically, it serves as a kind of the JSON glasses that you can put on to work with your more general kinds of data. JSON as a data model enables an ETL, extract, transform, load free, change tolerant world where if the application picks up some new fields, those can just flow naturally into Capella Columnar as new fields in the incoming JSON objects, and you can continue to work with your data. You don't have to go and sort of define a new schema and drop this and add that and so on. And also just to point out that the analysis can be over whatever data you have. Some of your data might be in static collections. Some of your data might be in more dynamic collections, and we'll talk more about that later on in the video. But your SQL++ queries can go over all of those separately or together. All right, so what are the key things that you get if you come and use the Capella Columnar service? And for those of you who are familiar with Couchbase, if you are familiar with Couchbase Analytics Service, this is not that. It's related to that, but it's not that. So this is sort of not your father's Couchbase Analytics. It's much more. What it offers is SQL++, SQL extension for dealing with JSON data in a very natural way with your SQL glasses. With your JSON glasses. It offers also the parallel execution of your queries. So analytics are often, sort of involve a lot of processing, and so we use massively parallel processing. We do parallel execution of the queries in SQL++. So we bring to bear a number of compute units in a sort of a virtual cluster in Capella Columnar. We'll bring those all to bear on processing the queries, as we'll see. Under the hood, implied by the name, we actually use a columnar storage format, and that's a format that sort of in the relational world was developed to be efficient for analytics. We extend that significantly to deal with JSON data, and we'll talk more about that. We have compute storage separation, and we'll talk more about that as well, so that the amount of compute you bring to bear can be sort of separate from the amount of partitions of data that you have stored. We'll come back to this. We have cost-based query optimization. So when you write your query, you don't have to worry about specifying how to execute it. We'll figure that out. And we have optimization that's aware of our columnar storage format. We also support continuous data ingestion, and we'll talk about that. We also support access to data that you might have outside in your data lake and separately, sort of from the data that's stored and managed within Capella Columnar, and we will talk about that. And then finally, you may have some favorite BI tools that you would like to use to interact with your data, and you don't have to change your favorites. We will give you access to columnar data. Columnar data can be seen through views that we'll talk about by your BI tools. So these are sort of the highlights of what's there. If we were to call out what's different from Couchbase Analytics, the red stuff is new. So Couchbase Analytics had SQL++ as its query language. It did parallel execution of queries over the data that it was storing and managing. And it had begun to offer BI tool integration. And it also offered ingestion of data from sort of the OLTP part of Couchbase world, from the data service into the analytics service, and the ability to do that data analysis. But now we also support continuous data ingestion from other data sources, as we'll talk about. So all the red stuff is new: the columnar storage, the compute storage separation, cost-based query optimization for columnar data, the data ingestion from other sources via Kafka, and sort of optimized access now to external data. We'll cover all of these things as we go through the rest of the video. Graphically, this is saying the same thing. So the Capella Columnar service is a sort of a columnar JSON database engine that has these technologies under the hood, starting with storage that's at the bits at rest live in S3. We'll talk more about that as well. Storage compute separation so that you can bring to bear varying amounts of compute resources against your stored data. These technologies that we'll be talking about. And then on the left, these are ways that data can come in. So you may have data in your on-prem Couchbase world, or you may have data in your Capella Couchbase Capella world, or you may be new and coming to us because you want to integrate your data in this new world of Capella Columnar. Some of your data may be in a relational database, MongoDB, DynamoDB, Cassandra, other data sources. Some of your data may be just sort of file data out living in S3 in your object storage. All of that data can be analyzed together, in fact, using Capella Columnar. And then in terms of how you see your data or talk to your data from Columnar, we support Power BI and Tableau for BI users. We have SDKs for applications with data APIs. There's a user interface that I'll give you a teeny glimpse of at the end. And then we also have this thing called IQ, which is sort of bringing LLM sort of Q&A to bear on how you can build queries. So let's look now at what are those technologies under the hood. Like, you've seen the picture, but what does that actually mean? What are each of those building blocks? And when you get them together, what power does that bring you? So let's start from the top. And you're a big company, you're an enterprise, you've got lots of data. So you may have multiple applications that are, shopping and maybe your sort of customer service and maybe social media. And you might have, sort of analysts back at headquarters. And your applications may each be using operational databases. Maybe you had chosen Couchbase for some of those. Maybe you had chosen some other technology for some of those, and some relational technology for managing kind of your, sort of your most boring business data, if you will. And what you'd like to do is you want to do some analysis. So typically you've got a bunch of analysts and they're all trying to answer questions and get insights and make predictions and make decisions based on sort of the union of this data. And so sort of in today's world, you may be sort of using ETL tools to bring those various sources of data together in a data warehouse, or you might be sort of more pouring them a little bit more in raw form into a data lake, maybe ETLing some of that later into a warehouse. And then over on the right-hand side, you've got your BI tools or visualization tools, or maybe your data science tools, notebooks and things, which are accessing the data from the warehouse. And so what you have is you've got data here and things may be changing and things are happening and you want to know, but you kind of have to wait for that data to flow across the data lake or go through the data warehouse so the analysts on the other side can analyze it. What Capella Columnar does is it makes that a much shorter wait. So what you can do if you are a Capella Columnar user is essentially that can bring together the data from multiple operational databases, from Couchbase and otherwise, and relational data, and bring them all together in the Capella Columnar service. And now a bunch of the analysts here who used to have to wait for, tomorrow or whenever their data got sort of into the warehouse, or worse yet, there was some new information that was added to the data and they have to wait first for the warehouse schema to be changed and then for the data to flow into the warehouse. All those waiters don't have to wait. There's still going to be some users who really need to bring, sort of the full power of what's in the data warehouse to bear, or the data lake. And so these analysts are going to, wait their normal wait. But a bunch of the analyses can now take place sort of much more quickly in near real time based on the data coming together from these different sources in Capella Columnar. The data might flow. We'll talk more about how that works. So I won't go into much more detail about that, but the data may be flowing over sort of Couchbase channels or Kafka as a non-Couchbase channel to have that data in near real time in Capella Columnar for that analysis to happen. You still may put that data in a warehouse or data lake later, but you don't have to do it right away. You can do this analysis immediately rather than having to wait until tomorrow or whenever to do it. All right, so now let's talk about sort of top down, if you will, the different technologies or the different features that Capella Columnar offers. So one of the things that we do is we allow you to use your BI tools. Things like Tableau and Power BI are the ones supported today, and we have sort of more on the wish list to analyze and to visualize your JSON data, not just relational data. So what this means is that a business analyst, they can use their favorite tools against data that's resident in Capella Columnar. Under the hood, what's going on is that Capella Columnar has sort of a JDBC or ODBC sort of hidden driver that allows these tools to issue SQL 92 compatible queries through that under the hood and get the results back. So BI tools are basically sort of interacting with the data as though it were relational, right? So they basically see a Capella Columnar database as a network of first normal form tables. But how can that be possible, right? I've been sort of selling you on the flexibility of JSON and nesting and all of that. The answer is there's a sort of a connection that's made between your tools and your data through what we call tabular views. So you have non-tabular data, but you can create tabular views. You can create the tables that you wish your business analyst could see by writing SQL++ queries. You can unnest and restructure your nested data with those queries, and then you can define them as tabular views. And sort of the signatures, if you will, for those views say, you know, this query returns the table with these fields and these types. And you can even wire those tabular views together by writing things like foreign key constraints. And those constraints provide the metadata that BI tools want to enable you to do drag and drop joins and things. The underlying data is still documents. The views aren't materialized, but it looks like that data is now tabular. So let's actually sort of show that here. So this is sort of a artist conception of tabular views. So maybe you have some customer data and your customers look like this. You have some order data, so orders placed by customers, and that looks like this, where you've got order number and, you know, what customer placed the order and when was it shipped, if it was shipped. And for each order, there's a collection of items that are nested inside the order. If you're using a document database, that's kind of what you'd want to do because that's a natural application-friendly representation of an order or a shopping cart, that kind of thing. And then you might have another collection of data about products. So what's the, you know, the SKU or the item number of the product, and what product category is it, and what's its name, and so on. So here we have three collections of documents, and we would like to use Power BI or Tableau to analyze those. And so we can sort of put on our tabular glasses, if you will, by creating tabular views. So the tabular view facility in Capella Columnar would let you create four what appear to be tables, one for customers, one for orders, one for the items within orders, and one for the products. And so what used to be three collections and some nesting is shown to the BI tools as these four tables. And also the tables are, I should stop here just and point out that these tables can be interconnected, right? So that the sort of the schema can capture the fact that the this order, like this item 460 with this quantity and this price is part of order 1002 and so on, right? So this data sort of turns into what appear to be separate tables, but not so. And they can be reconstructed then sort of by providing those foreign key connections and letting your BI tools sort of see the data in the way that they're used to as relational tables with interconnections, as opposed to as document data. So you can use your favorite tools and they can see the data this way. And you can sort of engineer or architect what you want to show from the data that's here. All right, what about query evaluation for JSON? So Couchbase Analytics and Capella Columnar use MPP, or what's called massively parallel processing, to make your queries run quickly and allow you to bring more resources to bear if they're not running quickly enough for you right now. And so what's under the hood is what's called partition parallelism, and that's applied to all aspects of processing your SQL++ queries in Capella Columnar. So a Capella Columnar instance, sort of a virtual cluster in the cloud, is built up of a number of compute units, and you can add more or take away some if you would like to. But however many you have, those are all going to work together to process each one of your queries. So you might be doing sort of simple things like projections and selections in relational parlance, and we will process those in parallel. Capella Columnar will use parallel algorithms to execute those, have all the compute units work on their share of the data. If the data is indexed, all the better, but the index accesses and then the data processing will also happen in parallel across all the compute units that are working on the behalf of your query. If you're doing joins or sorting or grouped aggregation or even window sort of based analysis of your data, there's parallel algorithms being used under the hood for all of those things that bring to bear all the compute units to make those run fast. And so what we're essentially doing, how to do this for relational data has been, known and studied over decades. We bring the last few decades of relational best practices, sort of all the good stuff that data warehouses and data lakes do under the hood. We bring those to bear on flexible JSON data. Including like if your data is big and your memory is not as big as your data, our algorithms efficiently spill to disk and read back in order to be able to process data which is much bigger than memory. And the fact that we always bring all the compute units to bear on your queries means that you can scale performance. If you are running half the speed you'd like to, add more compute units and you can double the speed. And we'll illustrate that in a second. And with columnar storage, because we sort of take your data and we store it column-wise, and we'll talk more about that too, you don't always access all the data that your query touches, only the columns of the data that your query needs to access. And in addition, if you have data that's external, and we'll talk more about this in a few slides in this video, partition parallelism of the same kind is brought to bear on running queries over your external data. So all the compute units each get a share of the external data to work on, and they work on their share in parallel. So let's just drive that concept home with one example. So suppose you have a mission-critical application like beer management, right? This is clearly important. And maybe one of your queries, if you're a big, sort of giant distributor of lots of beers, is, I get beers from a number of breweries. Breweries have an ID. And I'd like to know for each brewery, like how many beers are there? And so down at the bottom, maybe we have sort of 3 compute units sort of working on 3 partitions of data, and they each are information about beers. So we've got, one of the beers has the name Double, and it's from brewery 3. Another one of the beers has name Saison, and that comes from brewery 3 also. This beer is Pilsner, and it comes from brewery 2, and so on. And so the data is sort of divided into partitions. And now what we want to do is run a query in parallel. So what does that look like? So if we were to apply MPP to running this clearly important query, the first thing that the query processor would do would be figure out how to do it, but it would then go ahead and compute like a partial answer to this aggregate query on each node. So each node would compute for each brewer ID, how many beers are there? So what used to be this gets boiled down to, well, brewery 2 has 1 beer and brewery 3 has 2 beers. And those same partial answers are computed all at the same time on all the units. And then what happens in order to continue in parallel is that data gets reshuffled, repartitioned, so that for a given brewery, all the information from these nodes about that brewery end up on the same node for the next phase of processing. So all the information about brewery 2 is here, brewery 3 is here, brewery 1 is here. And so now we can complete the processing by adding up, how many did we see for these breweries, and come to the conclusion that like brewery 2 has a total of 3 beers, brewery 3 has a total of 3 beers by summing those numbers and so on. So again, just to replay that, so the MPP, we end up sort of first doing our local computing, and then we repartition the data, and then we continue in parallel, and then the final aggregation is sort of the union of the results across those nodes. So that's just one example of how parallelism is brought to bear on processing these kinds of queries. All right, so what about storage compute separation? I talked about that being important, and this provides a basis for a serverless experience, sort of pay-as-you-go analytics, so that the data doesn't always have to be sort of online and being paid for. So what you'd like is when the data is not being used, you'd like it to be sort of sitting at rest someplace that's inexpensive. And then when you need to access it and query it, you want to sort of activate it, if you will. And you may want to bring different amounts of compute to bear on processing that data. So storage compute separation is what makes that possible. So the data in Capella Columnar is owned and managed by the Capella Columnar Services storage layer. The bits at rest end up in S3. So S3 is used, if you will, as the final backing store for Capella Columnar, but it's not like your data in S3. It's data that's being managed by Capella Columnar with S3 as its final storage place, as the system of truth. Collections that are being used for your queries and where data is coming into, indexes over those and so on, are cached in NVRAM on your compute instances in Capella Columnar. You can sort of think of that in a working set-like way. And that caching happens when your query accesses the data, it's brought into NVRAM, and then it's going to be worked on from there for performance reasons. Updates will be written through to S3 so that they're sort of safely there. But you sort of the system itself is computing on the data in the NVRAM on the compute units. In order to allow storage and compute to be separated, collections are actually partitioned into a sort of a larger number of pieces, and then those pieces can be assigned, those partitions of your collections can be assigned to compute units in order to be then queried, essentially. So each compute unit is kept, knows that it's responsible for a set of assigned partitions. Columnar instances, your virtual cluster, if you will, can be scaled up or scaled down based on your performance goals, and that will result in reassignment of responsibility, and I'll illustrate that in a second. So what that turns into, if you're sort of a relational data warehouse geek, is sort of a hybrid between a shared nothing and a shared disk kind of architecture. Shared disk in the sense that any compute unit can be assigned to be responsible for a partition, but shared nothing in the sense that it only has, like, each partition has one compute unit responsible for it at a given point in time. So why is that important? Right. So what does that buy you? So storage compute separation allows you to have a picture like this, where maybe when you start, maybe you just have, for illustration purposes, like one node, one compute unit, and you're running some query over your data. Your data is partitioned into a number of pieces, and all those pieces are being managed by, and our node A is responsible for them. When you've been querying for a while, all those pieces will be sitting in the NVRAM on node A. And so when you run a query against that data, it might take, let's say, for example, 2 seconds. And you may be going, okay, 2 seconds, I don't have that much time. I really want my query to be twice that fast. I'd like it to run in 1 second. So what you can do then is you can choose to scale up your Capella Columnar instance. And what that will do is it will cause the responsibility to kind of be reassigned so that node B now becomes responsible for half the data. So node A is responsible for sort of storage partitions 0 through 3. And node B is responsible for storage partitions 4 through 7. And now when you run your query, they're going to work in parallel, like we just saw. And so what'll happen then is that query will now take 1 second, because half of the job is being done on each of 2 things at the same time. Right. So the storage compute separation enables that kind of scaling and that kind of performance tuning based on your performance goals for your analyses. All right. So that's another part of the puzzle. Let's go on and take a look at the next part of the Capella Columnar technology stack, which is columnar storage, from which the name of the service comes. So columnar storage has been around for a few decades in the relational world, very popular because it's very good for analytical queries. Basically, you can sort of a table, rather than being stored row at a time, is stored in a columnar way. And what that means is that if you have a table with 100 columns and you have a query that only needs to see 3 of them, you only have to access sort of those 3 columns worth of data, not all of your data. Generalizing that for JSON brings a bunch of challenges. And there's actually a blog that we'll be putting out in the near future about that. But some of the challenges are data bloat, because JSON is a self-describing kind of a heavyweight data model when you look at it from a bits per unit of information perspective. and we want to make that data block go away. Heterogeneity, because in JSON, a price in one object could be a floating point number, and a price in another object could be a string, and a price in a third object could be some complex object. So the data is not necessarily uniform in JSON. And then also, JSON data allows nesting, like we saw with line items inside orders, and arrays, like we also saw with line items inside orders in our example. And so what we do is a couple things to sort of make columnar ideas from relational work against the flexible, preferable JSON data world. So one thing that happens is that the columnar service automatically infers the schemas from your data as it's added to the system. As the data arrives and new data comes in looking different, the schema for your collections are inferred automatically. You don't have to tell us what they are. The system's job is to figure it out, like what part of your data don't we understand. So we separate schema from data to reduce data size. We also store data internally in an efficient binary format. It's not stored as textual JSON data. And all of those things are happening kind of under the hood as part of the LSM lifecycle. And I'll clarify that on the next slide. JSON collections, as I mentioned, are stored in a column-wise fashion with a generalization of the notion of column to enable fast analytical queries over JSON data. Right. So even though the data is now much more flexible, analytical queries tend to focus on, sort of little slices of the data, not all data all at once. And so you'd like to be able to get those same sort of slice efficiencies in the world of JSON. So in order to make that possible, under the hood storage format that's used by Capella Columnar generalizes the notion of a column to support nesting and heterogeneity. And then once you have these sort of generalized columns, all the data in a column is similar, of the same type, and is then much more amenable to compression and encoding. So in addition to the size gain that you get by separating schema from data, you get additional size gains by having data all the same kind together and therefore much more efficiently encodable. We still support secondary indexes so that you can accelerate query processing by creating indexes that are useful for the kinds of analyses that you're doing. And I just want to drive home the fact that there's no requirement for the data for one of your collections to fit in memory. So in the relational world, sometimes when people think about columnar, they're also thinking about like sort of main memory technologies. That's not this. Your collection can be your objects don't have to fit in memory in order to be analyzed. And sort of all of your data, regardless of where it came from or why it's in the system, can benefit from being stored and managed in this column-wise manner. So let's kind of take a look at that in terms of just sort of a picture of what's going on. So suppose you have two objects. You've got sort of a user, John, who's got one phone. You've got another user, Max, who's got a couple of phones. Maybe so John and Max are strings, and phone is a sort of an array of objects, and those objects are describing the various phones. And so maybe some of the objects have some of the fields, but not all of them. You've got this sort of flexible, nesty world. How do we turn that in Capella Columnar into columns, right? So basically this data, when it comes in, is stored under the hood in what's called log structured merge tree components, which are basically sort of a set of B trees that form a collection. And so when that data comes in, it goes into an LSM component that first lives in memory. And then when that data is written to disk, we basically take advantage of that time to sort of, as the data is coming in, we're inferring a schema to write that schema that we've inferred out to a metadata page, sort of, if you will, at the top of the LSM component that's going to be on disk, and then to separate the data rather than being in this kind of row form into columnar form. Right. So the schema basically says, okay, so we've got this, this collection of objects, and each object has a name and a phone. Each phone is an array, which is an object which has a type and a number. Name is a field, which is a type string. And then, sort of the type is another string field and so on. So this describes, if you will, the structure that's been inferred from this data. And then the data itself then can be looked at as columns, right? So that the names form kind of a generalization of column. The types form a generalization of column. This one didn't have type, so that's null. and so on. So now we sort of turn that data on its side. We're storing the names together, and then we're storing the types together, and then we're storing the numbers together. So this now looks columnar, except that it's coming from this sort of nested, more flexible structure. So that's happening under the hood on your JSON data and involves those challenges that I mentioned. And so sort of the things to remember about that is that the inferred schema and the data are stored separately, right? So the data storage is, the bits of your field values, but not your field names. And sort of the metadata page has the schema information, and then the data pages have the data. The data's together by type, by virtual column, and so it's very amenable to things like compression. All right, the next puzzle piece that I want to cover as part of Capella Columnar is what it does for optimizing queries. So basically what we do is we bring sort of the decades of research from the relational world, relational databases and relational warehouses to bear on JSON analytics queries. What we do under the hood is we have what's called the sampling-based approach to result cardinality and size estimation. So when a query optimizer is trying to decide how to run your query, it wants to think about like how big are the intermediate results going to be, and both in terms of how many and how wide. And so the way that that works in Capella Columnar is that we basically maintain samples. You sample each collection of documents that you have, and that little sample is basically used by the query processor, the query optimizer, to run little sample queries to figure out like how many results you're going to get and how they're going to be. And while those samples are being created, the system also captures the cardinalities of your collections and then uses those samples in a way that turns out to be very good for targeting complicated predicates, things like expressions, other kinds of expressions involving multiple fields or computations, function calls, and also dealing with cases where there may be correlations between fields in your documents. The optimizer uses these samples to make decisions about how to run your query. It runs little queries on samples while it's trying to figure out how to run your query in order to determine the best query plan, including things like which indexes, if any, to use, what join order to use, what join methods, how to do aggregation, and so on. And so kind of the bottom line is the technology that's used for doing query optimization in Capella Columnar is both more accurate and more powerful than what you can get if you try to do a more traditional histogram-based approach. So let's have a picture of that. So how does sample-based, cost-based optimization work? Well, basically, suppose you have a query like this, which is joining customers and orders have items inside, and the system wants to figure out, I've got this many orders, this big collection of customers, and this even bigger collection of orders. How should I execute this query? In order to figure that out, what Capella Columnar does is it basically, it's cost-based optimizer, which is trying to figure out what things will cost, will take a portion of this query. So notice that this query for customers, we're looking for customers where the address object inside the customer had a city sub-object like %Massachusetts. Okay, and so a little query against the sample will ask the question, well, how many sample customers are there? And notice that like predicate would be very difficult to estimate the cardinality of if you use traditional methods. And then there's another piece of that query, which is asking a question about orders. And that question involves like, does the order have an expensive item? And what's, sort of things like that. And so the system will execute a little query against the sample to say, okay, well, how many orders in the sample have that case where they're, the quantity times the price of an item is greater than this amount. So these little queries are run against these little samples, and then those are used to figure out how to run your query efficiently. So we'll get a much better query plan by getting that kind of information. All right, what about data that you might not want us to store and manage in Capella Columnar? You have enough data that you really want it just to be, files and object storage, or maybe you have an existing data lake that's out there in S3, for example. And so external collections in Capella Columnar give you a way to deal with that data as though it were stored and managed. So we have external collections as a notion, and something called dynamic paths that I'll say a little bit more about in a minute that allow you to do queries over external data, although are internal. So defining something as an external collection that's data that's really in S3 and files in S3 organized in some way, it will appear to be an internal collection. So you can query it just as though we were managing it for you. That external data can be JSON or CSV, TSV or Parquet. And then we provide some features that I'll again talk about on the next slide that allow you to specify like which data to include and exclude as part of a particular external collection, and even how to look at that data and see some attributes as being there that aren't really there. And I'll make that clear on the next slide too. There's also, in addition to support for defining external collections, there are commands in SQL++, data manipulation language, subset of SQL++ to read data from and write data to external collections. So there's a copy from statement to get data from S3 and put it in a standalone collection that's now stored and managed by Capella Columnar. There's a create collection as query statement that allows you to create a collection by running a query and populating the new collection from those results. And if those results are in external data, that's another way of getting a subset of your external data stored and managed internally now. And then there's copy statement that also goes the other way. So if you've got data that you'd like to put out there in your data lake or in S3 and leave it out there as an external collection, you can do that using the copy to command. So let's look at those both a little bit more. So suppose you have some external data. Here's our external data. The red part is the part we're going to want to query shortly. So ignore the red lines just for a second. So we've got data. It's in S3, a whole bunch of files, sort of data.json files stored in a directory hierarchy where we're calling, let's say this is review data for something, reviews of websites or of hotels or books or whatever. So reviews are by year. Within each year, it's by quarter. Within each quarter, it's by month. And then there's the data files, which may have multiple documents. Each may have multiple documents in them. So here's the data that's sitting in S3. You've got it out there, and you'd like to see it as though it were available for querying in Capella Columnar. The way you do that is you create an external collection. So let's create an external collection called My External Collection. You create it on this sort of container at some link, which is sort of a pointer to and credentials for accessing your S3 data. And then you can provide information about the data format, and you also provide information about the sort of the data paths that you would like to be traversed, if you will, in order to collect together the data that should be seen as this collection called My External Collection. And here we're saying, well, so everything in reviews, organized by year, quarter, and month in that order should be seen as forming this collection. And oh, by the way, that if you have things under a particular year, let's see that as an attribute called year. If you have things under a quarter, let's see that as an attribute called quarter. These attributes don't have to exist in your data, but they're inferred from the structure of your S3 storage. So now what happens? Well, you've got an analyst who's got a question. So I would like to kind of get the data from my external collection from 2019, Q1 or Q4. How does that get processed and parallelized also by Capella Columnar if it's external data? What happens is that basically that query has to be compiled. The process of compiling that query goes off and finds out the structure of that external data and also has the information from what you specified when you set up your external collection. And then that's then used to filter the data that's being accessed to only go for 2019, Q1, and Q4 data. And the system also, the metadata that it retrieves says how many files are there. Basically, then if you have sort of 3 compute partitions in your Capella Columnar cluster, they'll each be given a share of the files to process, and they will process those files in parallel, much as we saw with the parallel aggregation earlier. And that will sort of go off and answer that query by running parallel query over your external data. And when you did that query, you were able to talk about year equals 2019 or quarter equals Q1 or quarter equals Q4 as though the data contained year and quarter attributes. And that's because this path definition said, think of this structure as inferring those attributes. Now, you might ask the question, one way you might have gotten this data out there is that that's how it's structured in your data lake, but you might also be wanting to take data, like you have a My Reviews collection in Capella Columnar, and you would like to write it out. You can use a copy to query, say copy, and you can write a query that accesses the data that you'd like to write out. You say where to copy it to, and you can specify sort of the structuring path that you would like we saw on the previous slide. And I won't go through the details of this, but essentially by writing a copy to query, you'll end up writing these files to S3, and the data will be sort of structured from this collection of everything now into this sort of hierarchy in your S3 storage. So it's sort of round trippable in that sense structurally. All right, one of the last pieces of the puzzle that I want to talk about is how does data come into Capella Columnar? Some of it can be external, we just saw that, and some of it can be standalone collections that you actually put data into explicitly, but you can also get data flowing in continuously from DCP, which is the Couchbase internal data change protocol that is used to capture what's going on in the data service, or from Kafka, if your data is not Couchbase resident data. So let's talk about both of those cases. So if you have data in Couchbase Capella or Couchbase Server, data that's being put into the data service and updated in the data service can be streamed also into Capella Columnar. This is based on, for those of you who are familiar with Couchbase Analytics, what were called remote links in that. Capella Columnar essentially is listening to the data change stream from the data service and continuously creating a shadow of that data so that you can now do your analysis in Capella Columnar on the same information that's being changed over time in your Couchbase Capella or Couchbase Server instance. If you are not so fortunate as to have your data already in Couchbase, maybe you have it in something else like MongoDB or DynamoDB or Cassandra or a relational database, you can do the same thing essentially now with Couchbase Columnar by using Kafka, but we provide Kafka connectivity so that you can have essentially the same data change reflection, the same shadowing for other kinds of remote data. Based on Kafka from the remote connectors from the remote systems, you can think of Kafka essentially as sort of enterprise DCP in this role. And the result, again, is that now Capella Columnar has a up-to-date shadow of your source data that can be used for running your more heavy analytics queries without bothering the system where the source data is being created and updated. All right, to put that in a picture, if you've got Couchbase data, DCP will bring that data into your collections in Columnar. If you have data in other data sources with Kafka assistance, we'll get that data again into near real-time shadows in Capella Columnar, or you can just create collections in Capella Columnar and insert, update, delete data to your heart's content. So there's a variety of ways that you can have data here. And once you bring it together here, you can query it, both it and across it. So you may have data from multiple of these sources, and they can be queried together using your SQL++ query capabilities from Capella Columnar. All right, so enough about sort of a glimpse at the technologies. Let me just sort of summarize what we've seen. It's a lot, right? So I just want to go over it again. So it's much more than just columnar storage. You might look at the name and go, oh, columnar storage, sort of nice, but tell me more. Well, there's a lot more, as you've seen, right? So basically what Capella Columnar, the DBaaS service offering, the new offering from Couchbase gives you, is essentially an unparalleled parallel platform for doing JSON analytics, for integrating data from a variety of sources in JSON form and doing analyses to see what's going on. Pieces of that puzzle that we talked about, SQL++, which is essentially SQL for JSON. So bring your SQL skills and you'll be able to speak SQL++ fluently in very little time. When we're running queries, Capella Columnar uses MPP-based query evaluation. When your data is stored, it's being stored in a columnar format that's generalized to deal with all the challenges that JSON brings for doing that. Compute storage separation, so you can scale your cluster size, your columnar instance size up and down to meet your performance goals. How do we make those queries run fast? Through cost-based query optimization, also for columnar SQL++. And then your data can be arriving continuously and changing and evolving, and you can query it. It can be coming in via DCP, Kafka, et cetera. We provide optimized access, as I also mentioned, to data that might not be in Columnar, where you just want to leave it in S3, but you want to query it as though it were being managed. You want to mix it with data that is being managed. We have new support for that, including the dynamic paths that will allow you to not have to access files that are not relevant to your query. And then finally, BI tool integration. We kind of led with that, but you can also show your data to your favorite BI tools using tabular views and take advantage of you're familiar with those tools and the power of those tools. So that's kind of in a nutshell what Capella Columnar is. Way more than just columnar storage and not your father's Couchbase Analytics. You might wonder, like, when can I use this? This sounds great, sign me up. Hopefully that's what you're thinking. So right now we have private previewing underway. So we've had a set of early customers look at this and work with it. And there are more in process now. So we have private previews happening, and a J will be following sometime this year. This is just a little glimpse of one of the early versions of the UI. It's already evolved a lot, but here we have sort of your information about what collections you have, got a place to work on your queries. You can see the results of your queries. And then it's also goodies like sort of the IQ, the new offering from Couchbase, which allows you to sort of interact using intelligent query capabilities. You can ask questions like sort of how many orders do I have in this particular collection, and it'll form a query for you, and you can then go ahead and run that query. So there's a very nice user interface that kind of sits in front of this to be friendly for you as you work with the system. All right, that's all I'm going to say. I've said probably more than enough, hopefully not too much information, but we really wanted you to see kind of what is there in Capella Columnar, what all you get if you work with this service. So that is the presentation. You can find me by email at this address. You can find my colleague, Till, who's manager of the Couchbase Analytics and Couchbase Capella Columnar group at this email, and I would encourage you to get in touch if you'd like to learn more. That's it. Thanks.